Let's do a quick example with basic statistics. Let's suppose we have a wind tunnel. We're taking measurements. We take 10 velocity readings, and the sample mean that we calculate is 44.580. That's based on these 10 data points. I arranged them in increasing order, as we'll see later on in calculating the mode. This turns out to be a nice thing to do to make it easier. Let's suppose the true exact speed in the wind tunnel measured some other way is 44.63 meters per second. So let's calculate the following: systematic or bias error of the instrument, sample median, and the sample mode. Okay, well, the systematic or bias error is defined as the average of the readings minus the true value. So here, the average is 44.580, and the true value is 44.63 to 4 significant digits. So our systematic error is negative 0.05, and notice that the systematic error has only one significant digit when we do the proper significant digit evaluation in our answer. When we calculate the median is the middle value, and since I arranged these in order, we would choose this value. Since we have an even number, we have to average, so the median equal average of these two, which is equal to 44.575. However, we really should write that to the proper number of significant digits. We really can't expect 5 out of that. So if we use our roundup rules, we would round up, since this is a 5 and 7 is odd. So the median, I would report the median as 44.58 to 4 significant digits. And then finally, the sample mode. Well, the mode is just the value that occurs the most times. So we just look here, we have a 5.7 twice, 5.8, 9. But so 5.7 is the only one that occurs twice. So the mode is 44.57. Let's do another example with basic statistics. Here are 10 houses that were sold, the prices of 10 houses, rounded to the nearest $500. So, by the way, we would call this 3.5 significant digits. It's somewhere between 3 and 4 significant digits, so we'll call it 3.5. And we'll give all our numbers, our final answers, to the nearest $500 as well to be consistent. So let's calculate the mean, the mode, and the median. The mean is the simple arithmetic average. So we add the 10 numbers and divide by 10, and that turns out to be $323,400, which we'll round to the nearest 500, so this would be 323,500. And that 500 is the least significant digit. That's the mean. The mode is the value that occurs most frequently, and if we look at this set of numbers, none of them are repeated at all, so the mode is undefined. We don't have a mode in this particular data set. The median is calculated as the value in the middle, and I've arranged these in increasing values, so the middle value is in here. If we had an odd number of numbers, we would just pick the middle one. In this case, since we have an even number, we have to average these two. So the median is equal to the average of these two numbers, and that turns out to be 273,500, so it's already rounded to $500. And so that is the median. Just a very quick comment about the median versus the mean, or the average. The mean at 323,400 is here. And so notice that only 2 houses are bigger than the mean, whereas 8 houses are less than the mean. So the median, that's why median is often a preferred statistic for kind of the typical house cost. In other words, half of the houses were smaller than the median, and half of them were bigger than the median. That's why median is also often used in this kind of representation.